Hello everyone, we student of VIT from Division D Group 10 of Srinidhi, Priti, Sankhya, Tanuja, Harshada and Arya are going to introduce our topic which is cache memory.
Cache memory is a very high speed memory. It is used to speed up and synchronize with high speed CPU. Cache memory is placed between the CPU and main memory. It is costlier than main memory but is economical than CPU registers. It holds frequently requested data and instructions so that they are immediately available to the CPU whenever needed. When the CPU needs to access memory, it first checks the cache memory. If the data is not found in cache memory, then the CPU moves into the main memory. There are various levels of cache memory having different sizes, and size increases as we move up the level.
And now we'll be learning cache operations. Cache operations require the concept of locality of reference. A locality of reference is a phenomenon in which a computer program tends to access same set of memory location for a particular time period. In other words, we can say it is the tendency of a computer program to access instructions whose addresses are near one another. Now there are two ways in which data or instruction is fetched from main memory and gets stored in cache memory. These two are temporal and spatial. Now, temporal locality means current data or instruction that is being fetched may be needed soon, whereas spatial locality means instruction or data near the current memory location that is being fetched may be needed soon in the near future. There is a slight difference between temporal and spatial locality. In spatial locality, we are talking about nearly located memory locations, while in temporal locality, we are talking about actual memory locations that are being fetched.
So talking about hit ratio, we just go through the flowchart shown here. So first step is we receive address from CPU and we check that block contains receive address in cache or not. If it contains cache, then it fetches receive address word and deliver to CPU and the process is done. If it do not contains cache, then it access memory for block that containing receive address and allocates that cache line for main memory block. After that, load main memory block converts into cache line and deliver receive address word to CPU and the process is done.
I will explain cache mapping techniques. There are different types of mapping used for the purpose of cache memory, which is as follows. First, direct mapping. Second, associative mapping. Third, set associative mapping. Direct mapping. A particular block of main memory can map only to a particular line of the cache. Cache line number is equal to main memory block address upon number of lines in cache. Second, associative mapping. A block of main memory can map to any line of the cache that is freely available at that moment. This makes associative mapping more flexible than direct mapping. Third, set associative mapping. A particular block of main memory can map to only one particular set of the cache. Cache set numbers is equal to main memory block address upon number of sets in cache.
Advantages of cache memory are the cache is faster and smaller memory that is used for storing the data and is used more frequently from the main memory locations. A mapping function is used to correspond to the main memory block in the cache memory. A primary cache has less access time comparable to a processor register and it is always placed on the processor chip. Static random access memory is used in cache memory. On the other hand, main memory uses dynamic random access memory. Disadvantages of cache memory are this memory is more expensive than other memories like primary memory and secondary memory. Cache stores the data temporarily. If the computer is turned off, the data stored in them gets destroyed. Cache memory comes at an increased marginal cost than main memory, which can increase the cost of the overall system. Cache data is stored as long as the computer power.
In the following video, we studied cache memories. First, we reviewed basic concepts of computer memory. Next, we in-depth analyzed the cache memory. Then we learned how cache memories work and the different categories of them. Finally, we outlined how the context switching in CPU cores affects the cache hits and misses. We can conclude that caches are crucial memory devices for current computers. By using different techniques and a hierarchical structure, cache allows fast and efficient access to the computer memory.
If you like our video, please like, share and comment below.